All right, so in lesson 2, we're going to be looking at what the graph of a derivative actually looks like. So just a visual representation of finding that derivative and how it's going to compare with the original graph. And there's a lot of interesting things that we'll notice here. But first, there's some basic things that we want to remember. So let's say if I take this curve right here. Now we all, back in Math 10C, we all learned about slope. And basically, we know that if my graph is going up, we've got a positive slope. If my graph is going down, we've got a negative slope. And anywhere that is on a maximum or a minimum. So basically, if I take the tangent line to that, if I take the slope at that point, I know that my slope is actually going to be equal to 0. So again, if I have a straight line and I'm finding the slope, I know that's equal to 0. And this is actually kind of a key idea because that's going to help us graph our derivative quite easily. So some things to notice here, and again, this is just kind of like a summary of what I just said here. Horizontal tangents definitely have a 0 slope. And how that would go into the derivative function is that would now become an x-intercept. So again, if I have a horizontal tangent or a 0 slope in my derivative, that's going to become an x-intercept. If I have a positive slope, so if my graph is going up, that is going to correlate with a positive y coordinate in my derivative. And again, don't worry, it's going to make sense once we kind of take a look at some diagrams here. Negative slope, obviously the opposite, would be a negative y coordinate. And then asymptotes we're going to get into, and cusps and corners in just a little bit. And that's actually going to give us an undefined or a discontinuous stage at my derivative graph. So let's take a look here. There's one kind of cool thing, and this is going to make a lot of sense when we continue to go through our derivatives because I'm going to show you a way quicker way to find derivative than that first principles formula. The degree of the derivative is 1 less than the degree of the function. And this you're going to see very visually in just a couple of minutes. So it's asking for each function, sketch the derivative below it. Now, the first thing that I always like to do whenever I'm finding the derivative graph is to look for the zeros. So to draw the derivative graphs, we want to find the x values where our slope is equal to 0. So in this case, remember we're talking about slope of our tangent lines. So right here, maximum and minimum points are definitely where we are going to have a slope of 0, which is what we just mentioned a little bit ago because it's a straight line. Now, we know in this example, when x is equal to 3, my derivative is going to be equal to 0. Because again, don't forget, derivative is slope. At x is equal to negative 3, the slope literally equals 0. Same thing with negative 1. My slope is 0. Same thing with positive 1. My slope is 0. So all of those, that's kind of where I like to start, is just figuring out where are the zeros, and then we can go from there. And number 2, okay, what we want to do now is look at the slopes, whether they're positive or they're negative, and put in the corresponding quadrant. So remember, if I have a positive slope, if we kind of come back up to this table up here, a positive slope gives me a positive y coordinate, or a negative slope gives me a negative y coordinate. So what does that look like? Well, let's take a look back at my original graph here. I've got this part of my graph. We're just going to kind of cut it up into sections according to where those zeros are. What is this first slope? Is it a positive or is it a negative? You look, I'm going down, so that must be a negative. So that means from negative 3 and back, so anything less than a negative 3 has a negative slope here. That means if I have a negative slope, I must have negative y coordinates. So my graph literally has to be under the x-axis. So don't think of it even as like flipping the graph or anything like that. We're completely drawing a new graph, and we're just looking at slope. So let's look at the next little section here. From -3 to -1. Is my slope positive or negative? Positive, right? So everything in between -3 and -1 has to be positive. So everything up here has to be in the positive quadrant. Next, let's take a look from -1 to +1. Again, my slope is negative. So that means everything in here has to be below the x-axis. Now don't worry about like how far to go or any specific points. All we're going to be looking at is whether it's above or below the x-axis. And the last little section from +1 onward, obviously that's a positive slope, so therefore my graph is going to continue to go up. And we've got our continuous graph there. Okay, the last thing that I wanted to talk to you guys about before we move on, remember, was this little thing. Now it's kind of going to make more sense. The degree of the derivative is 1 less than the degree of the function. If I look at my first function here, what degree is that? Basically, it's degree 4, right? You can kind of look at your zeros here to tell you. So this is going to be degree 4. What do you notice about the bottom one? Degree 3. It is definitely 1 less than what we started off with. All right, let's take a look at number 2. This one, again, you can try and pause it and then try it yourself. This one, again, first step, I always like to take a look at where are my maximum and where are my minimums. Well, I only have one minimum right here, so I know that that 0, just happens to be already on 0, is going to be a 0 slope. So that point is not going to change at all. Okay, now I'm just looking for slope. So in this section, I know my slope is a negative. So that tells me that in this section, my slope has to be negative. Okay. Here, my slope is positive. So my slope is going to have to be positive. Now, if I look at this, I kind of drew it on a slant, but technically, this is actually a straight line. Because what degree is this? This is degree 2. It's an x-squared graph, right? In this one, it's a straight line, which tells us it's only going to be degree 1, which is kind of cool. All right, so let's look at some more examples here. These ones are a little bit trickier just because they have the corners and the cusps and maybe some asymptotes and that kind of stuff. So in number 3, we can literally say this is a corner. And if you take a look up at that little table back on the last page here, it says a cusp or a corner is an undefined or discontinuous point on that graph. So something is happening there. Now, if I take a look, remember my first step was always, okay, find a maximum or find a minimum. Well, in this case, a lot of people might think, okay, well, that must be my maximum there. But the problem with this being a maximum is because it's a corner or a cusp or anything really kind of funky that's going on there. In this case, if I try to find the slope at that point, remember I need to find a tangent line, which is a line that touches that point at just one point. Well, I could have a tangent line there, I could have a tangent line here, I could have a tangent line there, I could have heaps of tangent lines. So I actually literally cannot find the slope at that point. And that is what makes that an undefined or discontinuous point on my graph. So if I label this, I know in your notes it's not labeled, but let's say we do 2 and then 2 here. At that point, 2, 2, at that point 2, 2, I have to have an open circle. Okay. This slope, okay, I'm going to actually give this slope to you because it's a straight line. So I'm going to say that that slope is equal to 2. And this slope is going to be equal to -3 because it's a straight line. We can literally figure out what the slope is, right? We actually have a specific value for that. So I want to take a look here. I know that this is a positive slope, so that means that everything in there must be a positive y value. Therefore, if m is equal to 2, I've got my slope all the way at m is equal to 2. So my slope is actually going to be a straight line. My next slope is -3. So I know that it's going to have to be in the bottom quadrant. And I know that 2 and -3 is an undefined value, and that is going to continue on. So that one's a little bit trickier. You might want to practice a few of those. And again, just keep in mind that when you have a straight line, you can find the slope. Specifically, literally, with a number. And that's what we can actually put in our derivative graph. All right, and the last one here, and remember these ones are a little bit trickier, so don't worry if you're having a little bit of trouble, you just need to practice. So number 4, you can see that we've got an asymptote. And again, according to that table, we know that an asymptote is going to be equal to basically an undefined point on my graph. So I know that, I'll just give you guys a specific, let's just say 3 here. So, sorry, -3. I automatically know at -3 on my derivative graph that I am still going to be having an asymptote. Now, I want to take a look at each section. So this guy to this guy. What is my slope? Obviously, it's a positive, right? So in this graph, I'm basically kind of continuing with that same graph. There is no maximum, no minimum, nothing specific that I can put on the graph. But then the second one I know is going to be a negative slope. So same thing. I'm basically going to be drawing my curve underneath the x-axis. And remember, that's the main thing that we're testing you guys on is it above or below the x-axis? So the next example, if you flip over, this is more what you guys are going to be seeing. So it's saying sketch the derivative of a given graph, and we've got this little guy here. Now, remember, first thing, you might want to try this one on your own and then like just pause it and come back to the video. If I take a look at these specific points, remember I like to do my maximum or my minimum points first. So I know right here, x is equal to -4.5. Right here, x is equal to -3. And right here, x is equal to 0. So right away, immediately, we've kind of cut it into 4 sections there, and I'm going to put those points right on my derivative graph. Okay. Now we want to go through and see, all right, what's my slope? So now I'm just going to first look at this section right here. My slope is obviously a positive. So that means that my graph has to be positive. Needs to be up in my up above my x-axis. The next section from -4.5 to -3, obviously that's a negative, so that means that my graph has to go under my x-axis. In the next section, here to here, I've got positive, so that means that my whole graph has to be above the x-axis. And then the last section obviously is a negative, so it's going to continue to go down from there. Again, something to keep in mind and to always check. In this case, I automatically know 1, 2, 3, 4. This is degree 4. And in this case, 1, 2, 3, I know that that's degree 3. And it makes sense. Remember, it always goes down 1 degree. So we're good to go. The next one here, and this is just kind of the I'm going to wrap up this lesson after this. We're talking about, again, just kind of when funky things are really happening to our graph, when we've got asymptotes, when we've got cusps, because that can be just a little bit more tricky. So it's saying a function is differentiable, so we can find the derivative at x equals a only if the derivative is going to equal there. Or I'm sorry, exists there. So you must be able to find the slope at x is equal to a. And this is kind of what I was talking about before when we've got, let's say for instance, like a cusp here. Here, again, I can have an infinite number of tangent lines. So therefore, I cannot find the slope here. It's not going to work. Same thing at x is equal to -3. It doesn't exist. There's no limit. So therefore, I shouldn't say there's no limit, but it definitely doesn't exist because that point doesn't exist. So I cannot find a slope there. It's just not going to happen. And remember that derivative is slope. So let's kind of summarize this. It's saying that to be differentiable, the function must be continuous. Remember, that means that there's no kind of break in the graph and nothing really funky going on. Must be continuous at this location. Also, a function is never differentiable at a vertical asymptote and at a corner or a cusp or an endpoint. All of those will not give us a derivative. So it's saying in this example, this is not differentiable at, obviously, x is equal to -3, like what we were just saying, and x is equal to 2. So it's pretty standard. And I mean, you're kind of looking at it in this graph, it's pretty obvious to see like, ooh, that's kind of a weird part of the graph. And then you can kind of question, all right, can I actually find the derivative there? The last example is literally just doing this. It's just saying, identify the locations that are non-differentiable. So go ahead and try this, pause it, and then come back. Remember, you're looking for asymptotes, cusps, endpoints. None of those are going to happen. So obviously not differentiable at x is equal to c, to e, to f, because f is that little cusp there, and g, because g is an endpoint. So go ahead, guys, practice that on page 75. And we're going to get into a lot of really good derivative shortcuts in the next lesson. It's going to be awesome.